Hi guys, and welcome back to the ACE Academy. In this video, we will be looking at the vertical shift of the linear function. Now, in the previous video, we looked at the change in shape or the manipulation of gradient for the natural linear function. And in that video, and in that case, we multiplied the x in the natural linear function by some whole number to change the slope of the function itself. But here's a question for you guys. What happens when I add a whole number to x? Now that's a bit interesting. So the function that has been plotted already on the Cartesian plane that is on your screen right now has the equation y is equal to x. Now what I want to find out in this little activity that we're going to do together is what happens when I say y is equal to x plus 1. Now, what kind of manipulation is going to happen to this function? How is it going to change? So in order to do this, I think we need to plot this new function, correct? Let's apply this equation to a new function, okay? So starting at 0, we're going to substitute all our x values into the equation to obtain a y value, and we are going to use that y value to plot against the x value that we have substituted into the formula. So starting off at 0, 0 plus 1 is 1. 1 plus 1 is 2. 2 plus 1 is 3. 3 plus 1 is 4. 4 plus 1 is 5. Okay, now working backwards from the y-axis, working towards our left, we're going to start off at negative 1. Negative 1 plus 1 is 0. So we're going to plot that along the x-axis, right? Negative 2 plus 1 is negative 1. Negative 3 plus 1 is negative 2. Negative 4 plus 1 is negative 3. Negative 5 plus 1 is negative 4. And now we see that we have obtained the points for this new function. So by joining them together, and drawing in the function, we can now analyze this new function that we have created. So this yellow function that is on our Cartesian plane, let's have a look at it and see what we can find. The first thing that I notice is that it has a new x and y intercept. It's completely different to the origin. So if I'm looking at the y-intercept, that would be where x is equal to 0 on our y-axis, right? So that point, that y value at which the function cuts the Cartesian plane, at which it cuts the y-axis, would be 1. So this function would have a y-intercept of 1, right? And it would have an x-intercept, the point at which the function cuts the x-axis, at negative 1. Right. That's the first thing that I notice. If we are looking at the red function that has been plotted, the y is equal to x, we can see that this new function that we have plotted for the y is equal to x plus 1 has y values that are 1 unit higher than the previous function, right? So essentially we've added a single point to our y value answer. And we have increased the y value answer for every single x value that we have, which essentially raises the function by 1 unit. Now, our next little activity is going to see what happens when we subtract 1 from the natural linear function. So the equation would be y is equal to x minus 1. We're subtracting 1 from x, right? So if I'm going to plot this function, I'm going to start off at the origin, of course, and 0 minus 1 would be minus 1. 1 minus 1 would be 0. 2 minus 1 would be 1. 3 minus 1 would be 2. 4 minus 1 would be 3. 5 minus 1 would be 4. And if I'm working backwards from 0 going towards negative 5 to the left of my y-axis, I would go negative 1 minus 1 would be negative 2. Negative 2 minus 1 would be negative 3. Negative 3 minus 1 would be negative 4. And negative 4 minus 1 would be negative 5. Right, and we see that we obtain another linear function that has been shifted downwards by a single unit. Another important point that I want you guys to notice is this constant that we are adding or subtracting from the natural linear function is actually our y-intercept. So in the first equation that we have plotted, which is the y is equal to x plus 1, the y-intercept for the yellow function is positive 1. And if you look at the equation, we added positive 1 to x to obtain this graph that has been shifted upwards by 1 unit. If we look at the blue function, y is equal to x minus 1, we notice that the minus 1, this portion here, is actually my y-intercept, negative 1. Can you see that? So that's an important point to take note of when it comes to linear functions. Now in this case, your standard equation for something that has a vertical shift is y is equal to x plus q, where that q value is the whole number that you are adding or subtracting from the natural y is equal to x function. Keep in mind that these equations that I'm giving you with the letters are not the complete manipulation equation that you're going to be using in your exams. That will be covered in the last video of each section, right? So in this case, this is the linear function. So in the next video, we will cover the complete manipulation equation, which is also known as your standard equation. Until then, all the best, guys, and I hope you're understanding this so far.